Okay, so today what we're going to be doing is we're going to be finding the solutions that make these statements true. It says give answer or answers in degrees and radians. So when we look at this, when you're finding a solution to an equation, you're finding where the variable is. What's my variable? Theta. What does theta represent? So you're finding an angle. Also, if you read the directions and it says give answer in degrees and radians, hope you know we're finding an angle. Okay? So remember, if you're solving an equation, you have to do whatever gets rid of cosine. How can we possibly get rid of cosine? Inverse cosine. So basically you are doing inverse cosine of cosine theta. Then on the other side we're doing inverse cosine of negative radical 3 over 2. So inverse cosine cancels out cosine. You get theta is equal to whatever inverse cosine is of negative radical 3 over 2. Alright, that's how you solve an equation. That's how you get theta by itself. However, this is not a calculator question. Because this is, it doesn't say in the directions, but these are all special. So these you should not be able to, you would not be able to pull out your calculator. This will be on a non-calculator section. So I'm just showing you the process, but this is non-calculator. So what I'm going to do is I'm going to first look at the sign, if it's positive or if it's negative, and I'm going to figure out the reference angle. And then once I look at sign, once I figure out reference angle, then I can figure out the answers from there. So visual person, most of you visual people, or kinesthetic meaning hands-on, most of us not very successful when we do 100% of this in our head. And believe me, I've graded many quizzes and tests of people that do this stuff in their head and have mistake after mistake after mistake. It's okay. You can take an extra 2 seconds and sketch a triangle. You can do it. So actually, XY, what's it called? Coordinate plane. Yeah. So what I'm going to do is I'm going to look at the sign first. The cosine of theta equals negative radical 3 over 2. So I'm going to think negative. Where is cosine negative? On the left 2. On the left 2, because cosine is x. So cosine is negative in these two quadrants. See, I didn't even take time to make that a perfect triangle. I just put 2 triangles in those quadrants, so I know that I'm finding answers that are in quadrant 2 and quadrant 3. The next thing I think about is the reference angle. So now I'm thinking, when is cosine radical 3 over 2? 60 degrees? No. 30 degrees. Cosine radical 3 over 2 in a 30-degree angle. So I know that both of these reference angles are 30 degrees. So I did my sine. I found my reference angles. Now I actually have to find the angle that lies in quadrant 2 and has a reference angle of 30 degrees. So how many degrees go this way, leaving me 30 left over before I get to 180? 150 degrees. Second one is starting at 0, going all the way around to the third quadrant. 30 degrees into the third quadrant is 210. Since I had more than one answer, I put it in fancy brackets saying this is a set of answers for the same thing. It'll be like theta equals. And that's the degrees. It says we also need to do this in radians. So I'm going to totally think about this radians. I'm not going to convert because in your assignment, you don't do radians and degrees for every single question. You do like one section is all degrees and one section is all radians. So I'm not going to convert. I'm just going to pretend like I thought about this as radians from the start. So after I figured out which quadrant it was in, and after I figured it out it was 30 degrees, then my mind says, what is 30 degrees as radian? pi over 6. So pi over 6 would be the reference angle. So how many pi over 6's do I go through before I have one more pi over 6? And then the total is pi, which is 6 pi over 6. All the halfway around point, pi is 6 pi over 6. So how many pi over 6's is that? 5 pi over 6's. And then same question with the other angle down here. I've got 6 pi over 6 at pi, and then I go one more pi over 6. 7 pi over 6. Your bracket. I do not judge your brackets. As long as they are brackets, I do not judge them. Okay, let's do letter B. So, since we are trying to find where cotangent, yeah, it's the same answer that we're waiting for. We're trying to find where cotangent is equal to 1. I might think about that as being where is tangent equal to the reciprocal of 1, which is, oh, still 1. Okay, that's good. Because I don't have the cotangents memorized, I have my tangents memorized. So, but if you have cotangent memorized, that's fine too. So I need to think about what quadrant is tangent a positive number. 3 is one of them, and then 1. So we've got 2 quadrants, quadrant 1 and quadrant B. That's where tangent's positive, so that's where my answers are going to be. And then I need to think about the reference angle. It is 45. In order for tangent, which is y over x, or cotangent, which is x over y, to be 1, then both x and y have to be the same number. So 45 degrees. So now we just have to figure out the actual angles. So this one right here, 45, oh, it is 45 degrees, right? This is in the first quadrant, so it's the same number. So this one all the way around into the third quadrant would be 180 plus 45, 225. So I'm going to take that same thought process, but just think about it as radian. So what is 45 as radian? Pi over 4. And then I'm going to say halfway around is pi, which is 4 pi over 4. So one more is going to be 5 pi over 4. Do you think you can try C? Let's see if you can try C. Of course, I'll put the answer up, go over it, but I want to see if you can try it first. Not us. A lot of you are challenging me on that, on not drawing pictures, huh? So you're thinking to yourself, where is sign positive? First quadrant and second quadrant. You're thinking to yourself, well, sine of 30 is 1/2, so this must be 60 degrees. So my first answer is 60, my second answer is 120. In radian form, 60 is pi over 3. And then 2 60s, 2 pi over 3s, it's 120. D? Try D. I give you a tricky one?
No.
I don't know. The answer should not have any 45s in it. You're writing 45 for D. Stop it. What is secant? What is secant? Secant is a reciprocal of cosine. So if I do cosine and I reciprocate 1, I still get 1. Cosine is x over r, or if this is unit circle, just x. Where is cosine? No, where is x and r the same length? Where is the radius of the circle and the length of the x value? Both 1. There's only one place. It's on the x-axis. Well, it's on, I mean, it's not only one place, but yeah. So since this is 1, there's only one location. That's at the ordered pair 1, 0. It doesn't even work over there at pi or at 180 because that's negative 1, 0. So there's only one location. That's 0 degrees. If you put 0 and 360, that's totally fine. In your assignment, it's going to say, if it's 0 and 360, you only put 0. Like, it's going to say that in the assignment, but it doesn't say that in the notes. And if I write that as a radian, what 0 degrees is radians? 0. You zoomed out when I just explained it. Yeah. So in your assignment, it's going to say, put your answers like,
Oh, okay.
it's going to say, between, is that on the screen? Yeah, it's going to say, it doesn't say, it should say it here, but it doesn't say here. It's going to say between 0 and 360, but not including 360. It's going to say that. Because really, 0 degrees works, 360 works, 720 works, whatever the next thing is works. Like every multiple of 360 plus negative numbers, they all have the same answer. So we're going to limit it to just like 360 degrees. All right, the last section is with the calculator. Okay. This is exactly the same stuff that we just did, except you won't be able to do it in your head. So I look at sine theta equals 0.3892, and I say, how do I solve for theta? Well, I have to sine inverse both sides. Not us. So I have to sine inverse both sides. That means that I can cancel out my sine with my sine, and I just get theta. On the other side, I have inverse sine of 0.3892. So that would be one that I don't know. This is where I have to use my calculator. Now, it does say for the directions to do both degrees and radians. Let's all make sure we're doing the same at the same time. So can we do degrees first? Make sure your calculator is in degree mode. And I get about 22.9 degrees. And that's an approximation. Oh, I forgot to do something else first. I got way into it and just kept going. I forgot about this picture over here. Where is sine positive?
First one, first or second.
First and second. So I know I'm going to have two answers. One of them is 22.9 degrees. How would I find the other one? Okay, so the 22.9, not only is it the answer, but it's also the reference angle. So this is also over here 22.9, then I'm going to take 180, and I'm going to subtract off 22.9, but please do not do 180 minus 22.9. I want to see exact answers. So you should be doing 180 minus that last answer. Sometimes it matters, sometimes it doesn't. But we're going to keep the most exact, accurate answers possible. Do it this way. And if you're working ahead, you don't know what I'm doing next. So I might want these to be the last two things in your calculator because of what we're doing next type thing. So don't work too far ahead. So I'm going to show you a shortcut. Make it go fast. All right, so what is that answer? 157.1 degrees. And then there should be no reason why these are out of order. It should be lowest to biggest. Okay, you guys know how to put numbers in order. So that's degrees. Sorry, it's not quite. Now we're going to do the same thing, but we're going to do for radians. So you just kind of like think a different way, but the work really doesn't change. It's going to be the same basic work. Okay, so what I'm going to do first is go to my calculator, change my mode. And then I don't want to have to retype what I already typed. So I use second enter, second enter. You hit it twice and it just brings up what we did before. And then I hit enter and then I have my answer in radian. So then you have to retype stuff. So that's going to be my first answer. In your assignment, it's asking you around at the 10th, I think. So we'll go about 0.4. Now, does that 0.4 make sense for first quadrant in radians? Here's 0 radians. Here's 1.57 radians. Here's 3.14 radians. And down here is 4.7, I think, 1 radians. Does that 0.4 make sense for the first quadrant? Okay. Well, because if I got an answer like 1.9, then that wouldn't make sense. So my second one, just like I did for the degrees, I took 180 minus the answer. Well, I'm not going to take 180. What am I going to do? Pi minus answer. So you just do pi minus answer. 2.7, 2.7. And then look at your picture. Does 2.7 fit into that second quadrant? Does that fit in there? Okay, because people will tell me answers that don't go in the quadrant they drew. So check that. Okay. All right, how about the next one? Example 7, secant. Do we have a secant inverse button? No. We can't do secant inverse. So this is what my brain's thinking. Secant is what? The secant is equal to what? 1 over cosine. So my brain is thinking this is the same thing as 1 over cosine theta. So that's my brain thinking. Secant theta is the same thing. So I didn't do anything. I just said these are the same things. So there's not a secant inverse. There's not a 1 over cosine inverse. So what I'm going to do is magical. Since it's an equation, whatever you do to one side, as long as you do it to the other side, you can do. So I'm going to reciprocate both sides. You're allowed to do that. That's an actual reciprocal property that says, as long as I reciprocate both sides, they're still equal. So now I'm saying that the cosine of theta is equal to 1 over negative 2.3412. So I'm walking you through what I'm thinking in my brain because people confuse what we just did with something we did a few days ago. People confuse that. So now I have cosine, so now I can do cosine inverse. You can only do cosine inverse when we got cosine. Oh, I forgot to draw my picture first. Oh, and which mode are we in? Yeah, we're in we have to do both, but we're in radian mode right now. If you switched it back, sorry, I forgot to switch it back. 2.0 would be my first radian answer. We had to do both. Okay, so going back to my graph, I forgot to draw that first, so I could just, make sure I'm doing it right. Where is secant, which is cosine, where is it negative? In 2 and 3. So this is 3.14, up here is 1.57. Does 2 radians make sense for that? 2 radians fit between 1.57 and 1. Okay. Then what I need to know now, so this is 2.0-ish radians. I need to know, starting at 0, going all the way into the third quadrant, it's going to be bigger than 3.14. But it's going to be less than 4.71. How are we going to find that? There's 2 different ways we can do this. And they have an idea. Sorry, didn't see it.
If you subtract 2 from 4.71.
Nope, because 2 is this amount right here.
Okay.
So if I start there and subtract that amount, it's going to end up here. What? Add what?
Add the 2 to the 5.
Well, 2 is over 1/4, so if I add pi, it's going to be over there. I need to find the reference angle? Okay. So my reference angle is this theta over here. How do I find that? Sean?
You take pi and subtract 2.3.
Okay. So I'm going to take pi, and then I'm going to subtract off that last answer that I had. I'm not actually subtracting 2.0, right? I'm subtracting that full thing. Pi minus that answer, and now I have a reference angle, 1.129 something. So I know my reference angle. So what do I do with that theta to get here? Okay. Yeah, you take pi plus the reference angle, and that's where we'll get there. So now I'm going to do pi plus the reference angle. And to do that, though, I'm on my calculator doing pi plus that last answer I had, because I don't want to retype in anything and I don't want to round it. So I'm doing pi minus answer, then pi plus answer. It's all in the calculator, so it's few keystrokes. 4.3-ish. 4.3. And does that make sense for that quadrant? 4.3? Yeah. Okay. Now we do need to do degrees as well, so I'm going to go back to my calculator and change it to degree mode. And then I'm not going to retype in that cosine inverse. I'm just going to go and grab that from before. You can go up if you have the newer calculators, or you can just hit second enter, second enter, second enter. And I have my degrees as 115.3 degrees. And does that make sense for where it is in the second quadrant? Okay. And then where I did pi minus answer and then pi plus answer, I'm not going to use pi. What am I going to use instead? 180. So I'll do 180 minus answer, just 64.7, and then that plus 180. So 244.7. And that should make sense for the third quadrant. Okay, the last one, I actually want to change the last one. So sorry if you started doing it already. But there's some questions on your assignment that aren't in this review, and I want to make sure that we do one like the ones in your assignment. So let's do I'm thinking for 2 moments here. Let's do sine. Made something up. Really creative numbers. So how are we going to find theta? And by the way, I'm in degree mode now, so we'll find our degrees first. How are we going to find theta? Okay. So I got negative 7.1 degrees, and that's degree mode, so we know that's degrees and not a radian. But, as it does not say in the directions, but I have told you, and I'm going to tell you right now again, the directions in the assignment are going to say your answer has to be from 0 to 360. Is negative 7 between 0 and 360? It is not. So let's figure this out. First of all, where is sine negative? Sine is negative in 3 and in 4. So now when I find out that it is negative 7.1 degrees, I go here to the starting point and I go negative 7.1. That's telling me where this line is located, but that's not the answer I want. I want the answer to be coterminal with that, but I want it to be positive. So how do we take negative 7 degrees, find a positive coterminal angle? Add 360. Exactly. So whatever's here, I hit plus 360. 352.9-ish. Now, I actually didn't write that answer in my fancy brackets yet because that's going to be the second answer. I guess you could write it, but leave a space for your first answer. There you go. So now we need to find this starting at 0, going to here. Yeah, so the 7.1 is the reference angle. It's negative when it came up on our calculator, but the actual 7.1 is the reference angle. So if you do 180 and you add the 7.1, we should get that answer. And I don't like to retype stuff in. Do you know how I'm going to do it? I'm going to do 180, and then I'm going to subtract my answer. That becomes 12. See what I did there? It has to be bigger than 180. So if you add the negative, you're going to have a problem. It has to be bigger than 180. So we get 187.1. What? No! Recording. I think it just ends up being black in the recording, just for a moment. Got me louder. All right. Still recording, we're good. I mean, it's the last example we're doing anyway, but. So 187.1 degrees. There we go. So same way, let's just do radian. Same way, let's go change it to radian mode. And then I'm going to go back and put in my sine inverse, negative 1.2 or 0.1234. and I get a negative radian amount. So we're going to do this the same way. If you come up with a negative radian amount, it's going to be the same thing. What did I do when I got the negative angle? You can go back and look what I did. What did I add? What did I add?
So you're gonna add 2 pi.
I'm going to add 2 pi on, right? So I'll have 6.1, 6.2. And does that make sense for that fourth quadrant, 6.2? Like 6.28 is all the way around. And this is just a little bit under 7 degrees. So 6.2 sounds about right. And then remember what we had done was take 180 and then we added the 7 or minus the negative 7. So I'm going to do the same thing. I'm going to take pi and then just add the opposite of that. 3.3. What? Yeah, I just brought the negative down with it. Did I give everybody a copy? So do you have 5 minutes? Yeah. Oh, I'll grab it.
It goes right down to 360.
Oh.
It goes right.
Do you see the beginning? The first page says, "Do not use your calculator."
Yes.
Yeah, that's on the entire front page. No calculator on the entire front page. Definitely draw some pictures. They help. Trust me, they help. When you go to the back page, all of it's calculator. But what I want you to notice about all of these is they all say, what I said in class, they're going to go between 0 and 360, where it includes 0 but does not include 360. So if you get a 0 degree, don't also put 360. Okay, every answer you get should be between 0 and 360. Every answer will be a positive number. If you get a negative number, then you go look at your notes. What?
Can we show our work on a separate sheet of paper?
Yeah, if you want. Okay?